The Punnet square is one method of crossing in genetics. And it is very important because there are some crosses, especially when you get to the dihybrid cross, that it will not be very easy for you to do with your normal line crosses. That is when you see the usefulness of Punnet square. But we are going to start with monohybrid cross. You use Punnet square to determine the phenotype and genotype, or genotypic ratio and phenotypic ratio of a particular cross. For example, if you have something like this, you are given a cross between capital T, and this. You are given this cross, and you are asked to cross. You can normally do this with your normal line cross, right? But if you are to use the Punnet square is like the box method. So what you do is this. Now, for this first parent here, you split the genes, the alleles. So you have one T here and the other one here, right? For this other one, you split it. So you have one here and another one here. Do you get? Now the next thing is to fill in the boxes. So here we have capital T and small t, right? So here we have capital T, small t. Here we have capital T, small t, same thing here, capital T, small t. Here capital T, small t, capital T, small t. Sorry, this capital T and this small t, right? So capital T, small t. Same thing here, this and this. So these are just things. And if you observe, it is the same thing you get if you use your line process. Is it not? Is it not? Now, do you understand this method? Do you understand?
Yes.
Alright, so this will be useful when we take an example of dihybrid cross. Now we've seen monohybrid cross. For dihybrid cross, we said dihybrid cross differ in what? Two genes, right? We're looking at two contrasting characters. For example, we can cross parents that differ. Maybe one plant is tall and red, another one is short and green. You see, they have two different characteristics there, right? Yeah. That's dihybrid cross. And in dihybrid cross, you can do your normal line cross, or you can use your Punnet square method to do your crosses. Let's take, for example, if you are given a cross between, let's say, you have something like this. Now, if you are given something like this to do, if you are to cross this plant with this plant, now this plant is tall plant with a round seed, while this one is dwarf plant with rainbow seed. So you can see that we are looking at two contrasting characters, right? So if you are asked to cross this first one with this second one, how do you do that? How do you do that? You can use your normal crosses, right? You can use your normal crosses, but if you are doing that, you have to cross the traits differently. Is it not? You cross the traits differently. These tallness and wrinkles, you don't cross them together. But a very easy way to go about it is to use the Punnet square method. First of all, for you to use the Punnet square method, you have to segregate. Now, what I mean, you segregate, and segregation means the two alleles will separate from each other before it is passed on to the offspring. Because just imagine your dad, this is from your dad that codes for tallness, this is from your mom that codes for shortness. And both of them, no segregation, they are not separated. Your dad gives you this, your mom gives you this. Just imagine how it will look like. So, in this, if this one segregates, they are homozygous, right? So we have just one of it, homozygous, because the other one is still same as this. if this one segregates, you have just one of these two, right? Because they are homozygous. Times if this one segregates, you have just one of these homozygous and just one of these. There is no other possible combinations. Is it not? Alright. So now you can do your crosses now. You can do you can use your Punnet square method to cross, or use your normal crosses to do that. So using the Punnet square method, okay, you are using the Punnet square method. This is how it will look like. Here you can see, if you look at this, if you are looking at how these things can combine, just look up. This is what you are going to use. But if you have something like this, TT, arrow, arrow, and let's say you are crossing this, TT and the arrow, arrow. This one we combine with this to form what? T arrow, right? This one we also combine with this to form what? T arrow. This one combined with this to form T arrow. T arrow, right? So you see we have 4 T arrow. All of them the same thing, is T arrow. Is it not? So what you are going to feel here is this T arrow, T arrow, T arrow, T arrow. So here we are having T arrow, T arrow, T arrow, T arrow. Now, if you cross this one, you also notice that what you have is times arrow, arrow. You all have small t, small arrow, small t, small arrow, right? Is it not? All of them. So we feel small t, small arrow, small t, small arrow, small t, small arrow, small t, small arrow. Now, after doing that, we can now do our normal way of getting it. Capital T to small t, right? So capital T, small t, capital arrow, small arrow. Is it not? Capital arrow, small arrow. Yeah, capital T, small t, capital T, small t, capital arrow, small arrow. What's the next thing to write, please?
Capital T, small t,
capital arrow, small arrow. You notice that all of them will be the same, right? All of them will be the same. This is how it is done. Do you understand this? Only thing you do is segregate. Or if you don't want to go that way, just take the two different things here. This is one, this is another one. You cross these two to get what you put on one side. You cross this other one to get what you put on one side. Do you get that? If you've gotten what is here and what is here, you can easily do this, right? So just cross what is here, you get what is on one side. Cross what is here, you get what is on the other side.